Welcome again to West Virginia. I'm really struggling with this. Anyways, so we are ready for joke of the day because it is the best part of the day. Now, how do you get down off an elephant? You don't. You get down off a goose. Well, speaking of being a silly goose, let's quit being a silly goose and let's take a look at dividing polynomials by binomials. So what you need to understand about taking a polynomial, which remember, poly means many, nomial means terms. So I'm going to have many terms and I'm going to divide them by a binomial. Binomial means two terms. We've taken a look at dividing our polynomials, dividing polynomials by a monomial, by one single term. But now we're going to take a look at taking a polynomial and dividing it by two terms. A little bit more difficult than dividing it by one single term. So what you need to understand first is that it is very much like elementary school long division. Now, I'm going to give you an example of an elementary school long division problem so that you can kind of see the similarities to the processes. But before we get into that, you do need to understand that you are not taking just a bunch of numbers and doing the division. You are going to have variables in there. You're going to have terms. So you need to make sure that your terms are listed in descending order. Descending means going down. You can see here that I've got second power, first power. That would be basically to the zero power, because remember we talked about anything to the zero power is 1. So this is listed in descending order. You need to fill in zeros for any missing terms, which I know doesn't make any sense right now. We're going to see an example of that so you'll understand what that means. And then you simply do the division, very much like elementary school long division. So here's our first example. And in each one of these, we're going to divide. What you need to remember is that the bar means division, so we have to decide, are we going to divide up like this, in other words, the x plus 3 into the x squared plus 7x plus 12, or are we going to divide down, in other words, the x squared plus 7x plus 12? Well, you know that whenever you have a fraction and that bar means division, that indicates that we are always going to divide up. So in other words, what that means is I'm going to take my x plus 3 and I'm going to divide it into the x squared plus 7x plus 12. Now here's the point where I said we need to make sure that our terms are arranged in descending order, and they are listed in descending order here. Second power, first power, no power. We're not going to fill in zeros for any missing terms because I'm not missing any terms. I have second power, first power, no power, so nothing's missing. Now I'm actually going to do the division. Now, like I said, this is similar to elementary school long division. So let's recap what that looks like. Let's say that we had a problem where it said take a 24 and divide it into a 579. Well, in order to do that, what I'm going to do is I'm going to say, well, will this 24 go into just this first digit of 5? And it won't go into that first digit of 5. So now I'm going to say, will that 24 go into these two digits, 57? And in fact, it will. Now, what a lot of us will do is we'll take a look at the 2 and we'll say, how many times will 2 go into 5? It'll go in twice. So we'll attempt to use that 2. So that's what we're going to do here is we're going to say 24 will go into 57 twice. Where do you write that to? You write it above that division symbol. The next thing that you would do in elementary school long division is you would multiply. You take that 2. Now notice here, I'm not just multiplying 2 times 2, I'm multiplying 2 times the entire 24. That will be very important when we notice the similarities over here. So 2 times 24 is 48, and where do I write that 48? It goes right down here underneath. The next thing that we do in elementary school long division is we subtract that multiplication. So we'll take our 57, not the 579, but the 57 and subtract 48. And when we do, we get a 9. The next step in elementary school long division is to bring down the next digit. So this 9 that's back here will come down. Now notice I only bring down one digit. Like if there was, say for instance, maybe a 3 sitting back behind it, I would not drag down the 9 and the 3, just one single digit. Again, that would be very important over here to see the similarities. So what comes next? We repeat the process. You're going to hear me say this a lot. Repeat the process. Repeat the process. So when I repeat that process, I'm going to say, Well, how many times does 24 go into 99? Again, looking at the idea of 2 going into 9, just to get us an idea of how to start. 2 goes into 9 4 times, so I'm going to try and start with that 4. And once again, I'm going to repeat that process. So what I will do now is I'll take that 4 and multiply it to not just the 2, but the 24. And 4 times 24 is going to be 96. If I repeat the process, once I do that multiplication, I will write it right down here. And then after that, I will repeat the process, and I will subtract, and 99 minus 6 is 3. Now, we'll deal with this remainder idea here in the next example, but let's go ahead and take this process that's been established here and use it to do this division. So recall that the process said, I'm going to take that 24 and divide it into the 57, and in doing that, I'm going to take a look at the 2, and I'm going to say 2 times what would give me a 5. That's the idea that's going to happen here. I'm going to take a look at just this first term. Notice we said first digit. I'm going to look at the first term, and I'm going to say, what would it take to multiply to this x to create an x squared? Well, x times x would give us x squared. So what I'm going to do is I'm going to multiply by an x. And notice what we did over here is we said, okay, once we figured out what we're going to multiply by, we multiply that to not just to this first digit, but to everything. That's exactly what's going to happen here. I'm going to multiply the x to everything. Not just the x, but the x plus 3. So x times x is x squared, and where did we write that over here? We wrote it underneath. That's what we'll do over here. X times x will be x squared, we'll write it underneath. X times 3 is 3x, and a positive 3x, so we'll write it down underneath. Now recall I said what happened next? We subtracted. We're going to do the same process over here. So we will subtract. Now recall, I didn't just take 5 minus 4. I took 57 minus 48. In other words, I subtracted everything. Not just the 4, not just the 8, but the entire 48. That's what's going to happen here. I'm going to subtract this entire binomial. Not just the x squared, but the 3x as well. So what that indicates is I'm subtracting the x squared, I'm subtracting the 3x. So what I need to do here is I need to distribute that negative through so that I can subtract everything. So I'm going to distribute the negative here and turn it into a minus x squared. Distribute the negative here, turn it into a negative 3x. That turns this into an addition problem. So now I'm ready to combine up those like terms. So x squared plus negative x squared cancels out. I wanted that to happen. That's why I chose the x up here. So that x times x would be an x squared so that they would cancel out when I combined the like terms after I subtracted, or in other words, distributed the negative. So now 7x plus negative 3x, or in other words 7x minus that 3x, will give me a 4x. Notice over here, where did I write that subtraction? Where did I write the result? Underneath. That's exactly what I'm going to do here. I'm going to write down my result underneath. And then what was the next step over here? Recall, I drug down the next digit. That's the idea that it's going to happen over here. It's just it's not a digit, it's a term, but I will drag down. And notice I said just one digit. Exactly the same thing here. Drag down just one term, keeping the sign in front as the sign that goes. Drag that sign with it. And recall over here I said now repeat the process. That's exactly what's going to happen here. I'm going to repeat the process, and I'm going to say, okay, well now, what would I multiply to the x to turn it into a 4x? Well, 4 times x will be 4x, and more than that, a positive 4. And so we said over here we're going to repeat that process, and so that means we're going to take the next digit and multiply it to everything. That's exactly what's going to happen here. I'm going to take that positive 4 and multiply it to everything. So 4 times x will be 4x, and then 4 times 3 will be positive 12. And recall we said over here, repeat the process. In other words, let's subtract. That's exactly what we're going to do right here. Repeat the process and subtract. But remember, I'm not just subtracting that 4x, I'm subtracting the whole thing. So I'm going to put a parenthesis around this to remind me I'm subtracting the whole thing. That tells me I want to distribute that negative here. I want to distribute that negative here, turning it into a minus, kicks it into an addition problem. So now I'm ready to combine up those like terms. 4x plus a negative 4x cancels out. I wanted it to. This is great because that's why I chose the 4 right here. And 12 plus a negative 12 as well cancels out. And so I'm left with a remainder of 0. Now, over here, what would you report as your answer? In other words, where does the answer sit? The answer sits right up here as your quotient. So same thing's going to happen over here. Your answer sits right up on top. X plus 4 is going to be your quotient. Now, over here, how would you check to make sure that it's right? Like, let's pretend that our remainder was a 0. How would you check to make sure that 24 truly is your correct answer? Absolutely, you would multiply 24 times 24. You should get the number that's underneath. And if you do, then you know that this actually is the correct answer. Same thing's going to happen over here. In order to check it, what you'll do is you'll multiply your quotient to your divisor. When you multiply the two together, you should get the dividend that's underneath. So let's check and make sure that it truly is right. I'm going to take my quotient of x plus 4 and multiply the entire quotient. That's why I have parentheses around it. Multiply the entire quotient to this divisor, to the entire divisor. Again, that's why I have parentheses around it. When I do this multiplication, I better come up with the x squared plus 7x plus 12. Now, when you see this, you know that you're going to FOIL it, extended distributive property. X times x is x squared. X times 3 is positive 3x. 4 times x is positive 4x. And then 4 times 3 is a positive 12. Now I'm ready to combine up these like terms. And 3x plus 4x gives me 7x. So I have x squared plus 7x plus 12. Is that the dividend that I had underneath? It is, in fact, the dividend. Now, please note, this is not your answer. This is just the check. Recall that since it's a division problem, the quotient that's sitting up here, that is what your answer is. So, hopefully you're seeing here that when you divide a polynomial by a binomial, it's very similar. The process is similar to the process of long division. So, let's take a look at a few more examples just to make sure we get really good at this. Now, notice in this example that it's taking that x squared minus 36 and dividing by an x minus 6. And like we said before, what we're going to do is divide up. So that indicates that I'm going to take my x minus 6 and I'm going to divide it into the x squared minus 36. Now, here is where I said, okay, in those steps, I said, now, if you're missing any terms, you need to fill in zeros for those terms. My terms are written in descending order in this example. I do have x squared, no x to the first power, constant term, that's in descending order. But I'm missing my x to the first power term. So I need to fill that in with a 0 because in order for it to appear that it's not there, or appear to be there but not really be there, then that means that I need this to be a 0x. You'll understand here in just a minute why that is so important. So now I'm ready to do that division, and recall that what I'm going to do is I'm going to say, what would I multiply to the x to create an x squared? Well, x times x will be x squared, and I write that term up here above that, where the quotient is going to be, above that division symbol. So now what I'm going to do is actually do the multiplication, and recall that I'm multiplying that x to everything over here, not just this x right here. So x times x is x squared. I write that product underneath. And then x times negative 6 is a negative 6x. And recall that in elementary school division, what would come next would be to subtract. But recall I'm subtracting the whole thing, not just this x squared. So that indicates that I'm going to distribute that negative through. This becomes a negative x squared. This becomes a positive 6x. And that turns it into an addition problem. So now I'm ready to combine up those like terms. X squared plus negative x squared cancels out, which I wanted to happen. That's why I chose this x up here. And now 0x plus 6x gives me 6x. Hopefully now you're seeing why it is so important to fill in these empty slots with zeros. Because if this term was not here and you simply had x squared minus 36, when you try to combine this 6x, you can't combine it with any of those terms. Because it will not combine with an x squared, it will not combine with a negative 36. You would be stuck and not have anywhere to go. But filling in this term right here with a 0, I know that I have 0x plus 6x will give me a 6x. I actually can combine those like terms. So we write that result underneath, and then remember what comes next in long division, elementary school long division, would be to drag down that next digit. So I'm going to drag down that next term, and again, only one term. Now granted, there's only one term back there, but if you have extra terms, and you'll see an example of that, then you need to drag down one at a time. So now recall, I'm going to repeat the process. So what I'm going to do now is I'm going to say, well, what would I multiply to the x to create a 6x? I would multiply a positive 6. And I'm going to repeat that process, which means I'm going to multiply everything here by that 6. So 6 times x is 6x, which I will write that product underneath. And 6 times negative 6 is a negative 36. And then we said, okay, what comes next is to do that subtraction. And we said just be very careful because I'm subtracting the whole thing. I like to put parentheses around it to remind me I'm subtracting not just this 6x, but this negative 36 as well. So that indicates I need to distribute that negative through that parentheses. When I distribute it through, this becomes a negative 6x, this becomes a positive 36, and this becomes an addition problem. So now I'm ready to combine up those like terms. 6x plus negative 6x cancels out, which I wanted to happen. That's why I chose a 6 up here. And then negative 36 plus 36 cancels out as well to be a 0. So once again, I have a remainder of 0. Where is the answer? Absolutely right up here at the top. There's your quotient. But once again, how would we check this? Sure, let's multiply our quotient to our dividend, quotient to divisor, my mistake. Quotient to divisor, and when I multiply those, the entire quotient to the entire divisor, I better get the dividend that's underneath. So when I FOIL this, x times x is x squared, x times negative 6 is a negative 6x, 6 times x is a positive 6x, and 6 times negative 6 is a negative 36. Notice these two will cancel, and I'm left with x squared minus 36, which is what's here because I don't really have any x's there. In addition, it's what I have up here as my dividend. So I know in fact that this is correct, remembering that this is not the answer, that's just the check. My answer is the quotient that's up there on the top. Okay, so let's take a look at a few more examples again, just to make sure we're very good at this. In this example, yet again, we're dividing, and we know that we're going to divide up, which indicates I'm going to take my 2x minus 1, and I'm going to divide it into my x plus 6x squared minus 5. Now recall that first step said that what I'm going to do is I'm going to arrange my terms in descending order. Every example that we've seen so far had them in descending order. We didn't need to worry about that. But notice here, this is definitely not written in descending order because I've got x to the first power, x to the second power, and no x here at all. So I do need to do some rearranging. So I'll put my 6x squared first, and then I'll put my plus x minus 5. Now everything's in descending order. I do need to make sure that I fill in zeros for any missing terms. Nothing missing because it's second power, first power, no power, so that's good. I'm ready to do the division. So recall what that means is I'm going to take my first term here and I'm going to ask myself, what would I multiply to a 2x to create a 6x squared? Well, 2 times 3 will definitely create a 6. That's pretty good. But what would I multiply to this x to create an x squared? That would be an x. So I'm going to multiply this entire binomial, all of it, by a 3x. So 3 times 2 is 6, x times x is x squared, and now 3x times negative 1 is a negative 3x. And recall at this point now I'm ready to do that subtraction. But remember, I'm subtracting the whole thing, not just that 6x squared. And again, I like to put parentheses around the whole thing to remind me I'm not just subtracting the 6x squared, but all of it. That also reminds me I need to distribute that negative through. This becomes negative, this becomes positive, kicks it back to an addition problem. I'm ready to combine those like terms. One of the biggest reasons I distribute that negative through, because a lot of people say, well, that's a whole lot of effort, and I would simply prefer just to say, well, what I'm going to do is I'm going to take a 6x squared minus a 6x squared, and that's perfectly fine. That works great. But a lot of people get confused about x minus a negative 3x. That minus a negative kind of throws them off. A lot of people are very visual. So they need to distribute that negative through in order to see that when I subtract a negative 3x, it's really like adding a positive 3x. That's very helpful to a lot of people, prevents them from making mistakes. So that's why I go ahead and distribute my negative all the way through. So my 6x squared plus a negative 6x squared cancels out. I wanted it to, that's why I chose that 3x, so that needs to happen. And x plus 3x will give me a 4x, and like I said, we write that result underneath. And then recall, the next step in that elementary school long division was to drag down that next digit and only one of them. So I'll drag down the next term and only one of them. And then remember, I will repeat the process. So I will say, well, what do I multiply to a 2x to turn it into a 4x? Well, I would multiply by a positive 2. And then remember, in order to repeat that process, what I'm going to do is I'm going to take that 2 and multiply it to every term over here. So 2 times 2x is 4x, and then 2 times negative 1 is a negative 2. And now if I'm going to repeat that process, that means I'm going to subtract and yet again subtract the whole thing. And like I said, I like to distribute that negative because subtracting a negative 2 tends to confuse people. So I'm going to distribute that negative through here, distribute it through here, changing it to addition problem, and now I'm ready to combine those like terms. 4x plus negative 4x cancels. Good. I wanted that to happen. That's why I chose that too. And negative 5 plus 2 will give me a negative 3. Oh, wait a minute. This time we have a remainder. And we haven't seen that yet. So we need to go back and we need to say, now hold on a second, what do we do with that remainder? Well, let's go back to our elementary school long division problem. Back over here. And let's recall. When we had, let me get this out of here so we can see it a little bit more clearly. Whenever we had a remainder here, and our remainder in this case is going to be this 3, what did we do with the remainder? I know a lot of people are saying, well, we would just simply list an R3 like this, and that's true. But we are not in elementary school anymore, so we're going to stretch ourselves a little bit. Okay, once we quit listing it as R3, what did we do? Sure, a lot of people will say, well, we put a decimal point back here and string a bunch of zeros and drag zeros down like this. You are absolutely right, but the problem is I can't put decimal point 0 in these types of problems. So now what? Yes, the next thing that we did when we were in elementary school, we tried to figure out how to handle those remainders. We would take the remainder and we would list it over the divisor. So in this case, our answer really isn't 24. In this case, our answer is going to be 24 and 3 24ths. That's actually what our answer is, 24 and 3 24ths. Put your remainder over your divisor. Now, in order to check this with the remainder, think about what happens here. If I multiply 24 times 24, I will actually get a 576. But I need to take that 576 and I need to add the remainder, add that remainder in order to get the actual divisor of 579. So that's the process to check whenever you have a remainder. You still multiply your quotient to your divisor, but you add in the remainder to get the dividend. So if that's the case, let's take a look at this problem that we had where we ended up with that remainder. And we just said, okay, in order to check this, let's write our check up here. We said multiply our quotient to our divisor, my 3x plus 2, multiplied to my divisor, 2x minus 1. When I finish all that out, I need to add in that remainder, that negative 3. So I'm going to FOIL all this, and 3x times 2x is 6x squared. 3x times negative 1 is a negative 3x. 2 times 2x is 4x. And 2 times negative 1 is a negative 2. Once I combine all this, I need to combine it with that negative 3. Now these like terms will combine to be a 1x, so I have 6x squared plus x. Negative 2 minus 3 is a negative 5. Is that the dividend that I had right here? Yes, in fact it is. Which is the dividend that I had right here? So, what is my answer? Now be careful, it's not just a 3x plus 2, because remember, I need to include this remainder down here. We take the remainder, we put it over the divisor, that negative 3 over the divisor of 2x minus 1, and we add that in. Now there's a couple of ways that you can write this. You can either write it, let me clean this up for us a little bit. Okay, we've got our 3x plus 2 plus the remainder over the divisor. That's one way to write it. Another way to write it is just to simply say, well, I'm going to subtract my remainder over the divisor. Either way is perfectly fine. What most people prefer to do is they like to say, I'm going to add in the remainder and take that negative right up there. Either of these ways is perfectly okay. But you definitely need to include that remainder over the divisor as a part of your quotient in the end. And this will be your answer. Okay, so let's take a look at just a couple more examples again to make sure that we see everything we could possibly see. Nothing's going to shake us. Nothing's going to rattle us. We are very good at this. All right, enjoy the scenery. I started to erase that. I'd really rather not erase those steps. So I'm going to leave them up there. All right, let's try another one here. And I'm on example D. And we have a negative 2a plus a to the third minus 8 plus 3a squared all over a plus 2. Okay, so yet again, what I'm going to do is I'm going to divide up. And that means that I'm going to take my a plus 2. I'm going to divide it into all of this. Now notice I need to arrange my terms in descending order. Let me put that back up there. Arrange the terms in descending order. They are not. My highest power is a to the third. Descending order, 3a squared would come next. Descending order, my minus 2a would come next. And finally in descending order, my minus 8 would come last. So I've written everything in descending order. Let me clean that up. Boy, I'm really struggling here. So let me write this again. A plus 2 goes into a to the third. It's just all tightened up there. I want to give myself some room. A little bit better. Okay, so everything's written in descending order. We've seen the need for filling in zeros for missing terms. Now I have a to the third, a to the second, a to the first, no a. Okay, everything's in descending order. So I'm ready to do the division. So remember, what that means is I'm going to take my a and I'm going to say, what would I multiply to the a to create an a to the third? A times a squared would be a to the third. Now what I'm going to do is multiply that a squared to everything that's here. A squared times a is a to the third. A squared times 2 is a 2a squared. And now what I'm going to do is subtract. And recall, I am subtracting the whole thing. Put a parentheses around it to remind me that what I'm going to do here is I'm going to distribute that negative, distribute it here, and distribute it here and turn it into a minus that kicks it back into an addition problem. Now I'm ready to combine up those like terms. A to the third plus a negative a to the third cancels out. Good. I wanted that to happen. That's why I chose an a squared. If it doesn't, you better go back and check what you have right here. 3a squared plus a negative 2a squared will be a 1a squared. And recall, in elementary school long division, the next step was to drag down the next digit and only one digit. Aha! Now we see we have a couple of digits back there. But I'm going to drag down just one of them. Well, not digit, but term. And I'm going to drag down just one of them. Now I'm going to repeat that process. So I'm going to say, what would I multiply to my a to create an a squared? Well, I'd multiply by a positive a. And now if I'm repeating that process, I'm going to take that positive a, I'm going to multiply it to everything over here. So a times a squared, a times a is a squared. A times 2 is going to be a 2a. And if I'm repeating that process, what comes next will be that I'm going to subtract, and once again subtract the whole thing. So that tells me I'm going to distribute the negative here, distribute the negative here, kicks it back into an addition problem, and I'm ready to combine it in my like terms. A squared plus a negative a squared cancels out. Good, that's why I chose this. Negative 2a plus a negative 2a is a negative 4a. And now remember, Next step, drag down the next term, or in this case, the next digit. I'm sorry, drag down the next digit, in this case, the next term. Drag down that -8. And remember, always drag that sign in front, the sign that goes. Keep that name tag with it. You do not take that name tag off until you leave the room, and you always put it on the front. So the sign in front is the sign that goes, drag it with it. Now what I'm going to do is I'm going to say, what would I multiply to this a to create a -4a? I'd multiply by a -4. And if I'm repeating that process, what I'm going to do is I'm going to take that -4 and multiply it to everything that's here. -4 times a is a -4a. -4 times 2 is a -8. And if I'm repeating that process, what I'm going to do is I'm going to subtract. And once again, I'm subtracting the whole thing, which means distribute the negative here, change it into positive. Distribute the negative here, change it into positive. So a -4a, oh, and that kicks it into an addition problem. -4a plus 4a cancels to be a 0. -8 plus 8 cancels again to be a 0. I have a remainder of 0. Now, where is my answer? Yes, absolutely, right up here at the top. There's my quotient. That is my answer. Now remember, we can check this. How did we check it before? Absolutely, we multiplied our quotient to our divisor. We better get the dividend. Same thing's going to happen here. So when I go to check this, and I multiply my quotient to my divisor, I can either multiply the quotient a squared plus a minus 4 to the divisor like this, or I can put my a plus 2 in the front, my a squared plus a minus 4 in the back. Either way, what I'm going to do is the extended distributive property. So I'm going to take my a squared times a, and I'm going to get an a to the third. A squared times 2 is 2a squared. A times a is a squared. A times 2 is a 2a. -4 times a is a -4a. And -4 times 2 is a -8. And now I'm ready to combine up my like terms. There's no other a to the thirds, but this 2a squared combines with the a squared to be a 3a squared. The 2a combines with the -4a to be a -2a. And this -8 doesn't combine with anything. Is that the divisor, or the dividend, I'm sorry, the dividend that you had underneath? Absolutely. Which means it's what we had up there as well. Keeping in mind, this is not the answer, that's the check. The answer sits right here as the quotient. Okay, one more. Because in this, notice that everything we've done so far, we had one variable in there. Okay, it looked like a lot, but they were all a's. Even in these examples, nothing but x's, nothing but x's. What happens if you have multiple variables in there? Does it change the process? You're going to find out it doesn't change the process at all. The process will be completely the same, and the extra variables have a tendency to work themselves out. So, one last example here, and I've got an x squared minus a 4xy minus a 5y squared divided by an x minus 3y. So once again, what's going to happen is I'm going to divide up. I'm going to take my x minus 3y, divide it into my x squared minus 4xy minus 5y squared. And you may be saying, no, wait a minute, how am I going to write my terms in descending order? Well, you focus on alphabetical order, which x comes before y, and you would say x squared, x to the first, no x back here. It is in descending order. It feels very weird, but it is in descending order. And trust me, the extra variables work themselves out. So, and there are no missing terms because I've got x squared, x to the first, no x, no y, y to the first, y squared. There's nothing missing here. So I'm ready to do the division, and I'll say, what would I multiply to my x to create an x squared? Notice the process is the same here. I would multiply my x by an x. And you may be going, whoa, 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 there's a whole bunch of y's in there. It will work itself out, so just hang on. I multiply that x to everything that I see here. So x times x will be x squared. X times negative 3y is a negative 3xy. Oh, see? They are going to work themselves out. So remember, the next step is to say, well, I'm going to subtract, but I'm subtracting the whole thing. Put that parentheses around there to remind you, you need to distribute that negative all the way through here. So distribute it to here, turns it into an addition problem. Now I'm ready to combine up those like terms. X squared plus negative x squared cancels, good, that's why I chose that. But a negative 4xy plus a positive 3xy becomes a negative xy. See, they are working themselves out, and they will continue to work themselves out, so don't stress about this. Now remember, the next step is to drag down the next term. So I'm going to drag down this term, and I'm going to repeat that process. So that means what I'm going to do now is I'm going to say, well, what would I multiply to the x to create a negative xy? Well, I certainly would multiply by a y, but I also need to multiply by a negative, because negative times positive will give me negative, and y times x will be an xy. Now remember, I'm not multiplying that just to this first term, but to everything over there. So negative y times negative 3y will be a positive 3y squared. See, they are working themselves out. No need to stress at all. So I'm going to subtract, and recall I'm subtracting the whole thing, which means I'm going to distribute that negative through, change that sign, change this sign, kick it back into an addition problem, and now I'm ready to combine up those like terms. So a negative xy plus xy cancels out. Great, that's why I chose that. Negative 5y squared plus a negative 3y squared is a negative 8y squared. And notice that there is nothing back here to drag down. This, I'm stuck. I can't do any more division. So I have a remainder of negative 8y squared. And recall what we said before. What do we do with that remainder? We put it over top of our divisor. So we add it in. Let me go ahead and go with the same color here. Add it in as the remainder over this divisor. And there we go. That's our answer. And again, you could write it this way, or you could just write it as subtract the 8y squared over x minus 3y. Anyways, perfectly fine. But recall, in order to check it, and that's the beauty of these, you can check every one of them to make sure that they're right, even though this feels a bit cumbersome. It feels like, man, there's a lot there to check. But it will work out. Because remember, with that check, what we do is we take our quotient, multiply it to our divisor. So take that x minus y, multiply it to my divisor of x minus 3y, and I'm going to add in this remainder. When I do, I better get the divisor, the dividend. I keep saying that. Get the dividend that's right there. So I'm going to FOIL this. X times x is x squared. X times negative 3y is a negative 3xy. Negative y times x is a negative xy. And negative y times negative 3y is a positive 3y squared, combined up with my remainder here. Here's my like terms. Negative 3xy minus xy is a negative 4xy. And I've got more like terms here. 3y squared minus 8y squared is a negative 5y squared. Is that the dividend that I had here? Absolutely it is. So I know that this quotient that I have listed is correct. So hopefully you're seeing that when it comes to taking a polynomial and dividing it by a binomial, it is very much like that long division. Let me go ahead and put that back up here, because it really is like long division. And so those steps are very much the same processes as we had with our long division. The only difference is, well, now we've got terms in there instead of digits. So we need to make sure that we arrange those terms in descending order, that we fill in zeros for any of the missing terms, but then we go ahead and do that division. And we say, what would we multiply to that first term to create the first term here? Multiply everything here by that factor. Write it underneath, just like long division. Subtract just like long division. Write your result underneath and drag down the next term, and then repeat the process, and you keep repeating the process. And then to check, multiply your divisor to your quotient, get the dividend underneath, and then like we said before, if you have a remainder, just simply take that remainder and write it over top of the divisor, and then when you check it, just add that remainder in. I hope it helps. Have a great day.